In this video we shall discuss physical database modeling sample. Once again we have to mention that in real life this is a long iterative process that may take a lot of time. And even here you may want to pause the video or review the video several times. Let's start with a quick reminder. This is the information we have from the customer. This is our result of data logical modeling, so we have such a schema. And now we have to work with access permissions, encodings, storage engines, indexes, and DB or DBMS settings. Let's assume we want to use multi-user access permission mode, so we have to create users in DBMS for our application, for guest users, registered user, moderator, and administrator. And for each database object, each role must have or have no some permission. If you are not familiar with this abbreviation, it comes from the next words: create, read, update, and delete. So create, read, update, delete, CRUD. And you may see that, for instance, for this object, this role has all permissions, and this role can only read. So how can we set all those permissions? The only solution here is SQL code. In a couple of minutes we shall see how it works in real environment. So this is just the code itself, and we of course should change those placeholders for real passwords and then execute the code. For encodings there are several ways how to deal with them. We may use properties of a table, open tagged values, add those tagged values, and here's the result. Or, for instance, we may create such a stored procedure and then just call this procedure and it will set proper encodings for all tables in our database. In a couple of minutes we shall see how it works. Storage engine settings are similar to encoding settings. We open properties, tagged values, add information about storage engine, and here's the result. Or we may update our stored procedure and pass not only encodings but storage engine information, and then the procedure will set that storage engine for all tables in our database. We've already spoken about indexes several times, so here is just an example. Imagine that we have to speed up the following operations, the following queries for expired files deletion, file search by name and extension, file ordering by size, file ordering by creation date time. We may create such indexes using Sparx Enterprise Architect or SQL, but here is the result of some experiment. Imagine we have a table with a lot of rows and we want to delete expired files. We use explain for this query to see what indexes DBMS may use, and we see no indexes here because no index exists. Then we create an index and run that query again. Here is the result. We see that the DBMS may now use some index. And these are results of query execution: before index, after index. We see that with index DBMS works 120 times faster. That's extremely good result. If we see no changes here, something like 1 with something, or even if we see that this time is bigger than this one, we may just delete the index and return to the initial situation. And here's the SQL code for all those 4 indexes, for all those 4 tasks. And here are our indexes. To set some DB or DBMS settings, we may also use SQL. Examples are here, or we may use some text description for our colleagues to perform some changes manually. But please remember, do not provide ready configs, only provide such a description. Otherwise, someone will surely copy-paste your config with some good settings in some incompatible settings. To avoid such a situation, provide just a description but not the config file itself. And now we shall see some examples in real environment. First we have to deal with access permissions. This is the code from a couple of minutes ago. We've only added some passwords, strong passwords here, and if we execute that code, we see that everything went okay, and for now we may use such login and such password, or such login and such password to log in to our database and communicate with it. Next we have to deal with encodings and storage engines. We go to Properties, Tagged Values, click Add New Value. To speed up the process I have something prepared here, so I just copy-paste it. Okay, collate UTF-8 general CI case insensitive, adding new default character set with value UTF-8. Here it is. And the storage engine here in DB here. All done. And this information will appear in our SQL code. If for some reason I do not want to use Sparx Enterprise Architect for this task, I may use such a stored procedure. It's already created here, and now I just call it. So I select this code, click Run, and we see everything is okay. Of course, 0 rows affected because we do not change any data, but these changes were made to all tables in our database. The next thing is indexes. We may click Features, Constraints Indexes, and we see a lot of indexes already here. If I want to create another, for instance, some IDX, TMP. Okay, here it is. Yes, this is index, and for instance I want to index these two fields. Here it is, all done. If I do not want this index anymore, I can delete it. And of course I may use SQL to create indexes. I cannot execute this code now because these indexes are already created, so this code will lead to error. But if I have no those indexes, I can just click execute and these indexes will appear. And the last thing here is some settings of our DBMS and database. For instance, I want to change default collations and encodings for the server. I may execute such a code. You see everything okay? Collations changed. Or I may execute such a code. Everything okay. Or I may change these settings permanently. These persist words mean that after restart of the server, these changes will remain. And of course, Sparx Enterprise Architect allows me to create stored procedures, functions, sequences, SQL queries, and so on. We'll discuss all these in some next videos, and you may see here the result: stored procedures, views, stored functions, and so on. So Sparx Enterprise Architect allows us to do a lot of good things. So that's all about database modeling, and in the next video we shall review the reverse process, the reverse engineering.